Myself Sunitha, Assistant Professor of Mathematics Department in H&S from Tigala Krishna Reddy Engineering College. Today I am going to teach higher order differential equations. Linear differential equation of higher order with constant coefficient. An equation of the form d power n into y by dx power n plus p1 into d power n minus 1 into y by dx power n minus 1, p2 into d power n minus 2 into y by dx power n minus 2 plus and so on, plus pn into y equal to q of x. This is equation 1 or higher order linear differential equation. Here p1 comma p2 and so on, pn a real constant and q of x is a continuous function of small x, is called an arbitrary linear equation of order small n with constant coefficients. Then operator capital D. Let us denote d by dx, comma, d square by dx square, comma, and so on, d cube by dx cube. D by dx stands for capital D, d square by dx square stands for capital D square, d cube by dx cube stands for capital D cube. So capital D into y means derivation of y. So d by dx of y. D square into y means capital D square into y means so second derivation of y. That equal to d square by dx square, small d square by dx square into y, and so on, d power n into y equal to small d power n by dx cube, d power n by dx power n into y. So equation 1 can be written as in operator form, d power n into dx power n stands for capital D power n plus p1 into d power n minus 1 by dx power n minus 1 equal to small d power n minus 1 plus p2 into d power n minus 2 into y by dx power n minus 2 equal to capital D power n minus 2 plus and so on, pn. Here taking y common, that equal to q of x, right hand side equal to q of x. So here f of d equal to d power n plus p1 into d power n minus 1 plus p2 into d power n minus 2 plus and so on plus pn. Here it can be written as capital F of d into y equal to q of x. So f of d is a polynomial in capital D. The symbol d stands for the operation of differentiation. Then general solution of f of d into y equal to q of x. F of d into y equal to q of x means higher order linear differential equation with constant coefficient. This equation having two solutions. So first one is complementary solution and then second one is particular integral. So here y equal to yp is a particular solution of f of d into y equal to q of x. Total equation, higher order equation of linear higher order differential equation with constant coefficient, that is particular integral. Then f of d into y equal to 0 having complementary solution. General solution of f of d into y equal to q of x equal to y equal to yc plus yp. So y equal to yc plus yp is the general solution of f of d into y equal to q of x. To find the general solution of or complementary function of f of d into y equal to 0. F of d into y equal to 0. F of d into y equal to 0 means equation having complementary solution. So the algebraic equation f of m equal to 0, equation 1 can be written as in place of d, that equal to m, that is m power n plus p1 m power n minus 1 plus p2 m power n minus 2 and so on, plus Pn equal to 0. Here P1, P2 and so on, Pn or real constant is called, here expression of f of m is auxiliary equation of f of d into y equal to 0. Since the auxiliary equation f of m equal to 0 is a polynomial equation of degree small n, it will have n roots, that is m1 comma n2 comma and so on mn. The solution of roots. Roots of auxiliary equation of f of m equal to 0. First one is all the roots. Equation having f of m equal to 0. That equation having n roots. All n roots m1 comma m2 comma m3 and so on mn. That is all roots are real and distinct. Distinct means different. All n roots are real and distinct. Then complementary solution c1 e power m1x plus c2 e power m2x plus and so on plus cn e power mnx means c1 e power first root into x plus c2 e power second root into x plus and so on plus cn e power nth root into x. Then case 2, here two roots are real and equal, remaining roots are different. Means first root and second root is equal, third root, fourth root and so on nth root are different. Then particular solution, two roots are equal. First two roots, c1 plus c2x e power m1x, this is common root c1 and c2, two roots, plus c3 e power m3x, here different roots, plus c4 e power m4x and so on, plus cn e power mnx. Then third case, three roots are equal or real and remaining roots are different. Here m1, m2, m3 equal and m4, m5 and so on mn are different. Then complementary solution, three roots are equal, c1 plus c2x plus c3x square e power m1x plus c4 e power different root, c4 e power m4x plus and so on plus cn e power mnx. ఏం లేవు అడుగుతున్నా ఏం లేవు. And fourth one, two roots of auxiliary equation are complex. So say alpha plus or minus I beta and the remaining roots are real and different. Here complex roots solution yc means complementary solution of complex roots e power alpha x into c1 cos beta x plus c2 sin beta x. Here it complex roots plus real roots c3 e power m3x plus and so on c power n e power mnx. So case 5, a pair of conjugate complex roots alpha plus or minus I beta and repeated twice. So complex roots are repeated twice and the remaining roots are real and different. Then complementary solution e power alpha x c1 plus c2x cos beta x plus c3 plus c4x sin beta x. Here complex roots are equal, twice repeated, plus then real roots c5 e power m5x plus and so on plus cn e power mnx. Next case, a pair of conjugate complex roots alpha plus or minus I beta are repeated thrice and remaining roots are real and different. So complex roots are repeated thrice, e power alpha x, then complementary solution e power alpha x c1 plus c2x plus c3x into cos beta x plus C4 plus C5x plus C6 x square sin beta x. Here complex roots are thrice repeated plus remaining roots are real. C7 e power m7x plus and so on Cn e power mnx. The note point, if alpha plus root beta is a real irrational roots of f of m equal to 0, alpha minus root beta is also a root of an equation, part of the complementary function corresponding to these roots can also be put in the form or complementary solution of alpha plus or minus root beta is yc equal to e power alpha x c1 cos h root beta x plus c2 sin h root beta x. Then particular integrals. To find the particular integral of the f of d into y equal to q of x. Here right hand side function is there, q of x. This is particular integral. Find the particular integral. Given integral is f of d into y equal to q of x. This is equation 1. So operating 1 by f of d, we get 1 by f of d into y equal to 1 by f of d into q of x, or multiplying 1 by f of d. Equation 1, y equal to 1 by f of d into q of x, or so f of d sent to right hand side, y equal to 1 by f of d q of x. Clearly equation 1 is satisfied. We take y equal to 1 by f of d into q of x. To find the particular integral of f of d into y equal to q of x, here so many methods are there. First one, general method of finding particular integral. So general method of particular integral of f of d into y equal to q of x, when 1 by f of d is expressed as partial fractions. So in the denominator, f of d is expressed as partial fractions. So let f of d equal to d minus alpha 1, d minus alpha 2 and so on, d minus alpha n. Then yp or particular integral of 1 by f of d into q equal to, here f of d expressed as partial fractions, d minus alpha 1 into d minus alpha 2 and so on, d minus alpha n into q. Here it can be written as unresolving partial fractions a1 by d minus alpha 1 plus a2 by d minus alpha 2 plus and so on plus an by d minus alpha n. So resolving into partial fractions into q. Here a1 by d minus alpha 1, it can be written as, so particular integral of this fraction. So a1 into e power alpha 1 into x integral over q into e power minus alpha 1 into x dx plus a2 into e power alpha 2 into x into integral of q into e power minus alpha 2 into x into dx plus and so on nth term. So an e power alpha nx into integral over q into e power minus alpha n x into dx. So related one problem. So solve d square minus 5d plus 6 into y equal to x into e power 4x. So we apply the concept of general method of particular integral and complementary solution. So given equation can be written in operator form, already given in operator form only, d square minus 5d plus 6 into y equal to x into e power 4x. This is equation 1. Here auxiliary equation, in place of d substitute small m, f of m equal to 0. Here m square, f of d equal to f of m. Here in place of the substitute small m. So m square minus 5m plus 6 equal to 0. This is equation 2. The roots of equation 2. So 2 comma 3. It can be written as m minus 3 into m minus 2. So m equal to 2 comma Okay. So 2 comma 3 are which are real and different. So complementary solution yc equal to c1 e power first root m1x plus c2 e power second root m2. So here first root 2 and second root 3. So yc equal to c1 e power 2x plus c2 e power 3x. Now particular integral y equal to 1 by f of d into q of x. Here it can be written as y equal to 1 by f of d. 1 by f of d means 1 by d square minus 5d plus 6. So 1 by d square minus 5d plus 6 into x into e power 4x. So in denominator f of d it can be expressed as d minus 2 into d minus 3. This is partial fractions. Resolving into partial fractions a by d minus 2 plus b by d minus 3. I'm solving that a equal to 1, b equal to minus 1. So it can be written as 1 by d minus 3 minus 1 by d minus 2 into x into e power 4x. So partial fractions can be written as 1 by d minus 3 minus 1 by d minus 2 into q equal to x into e power 4x. So separating the fractions 1 by d minus 3 into x into e power 4x minus 1 by d minus 2 into x into e power 4x. So which is of the form, first fraction which is of the form a1 by d minus alpha 1 into q of x. Here alpha 1 equal to 3, q of x equal to x into e power 4x. Here this fraction is a2 by d minus alpha 2 into q of x. Here alpha 2 equal to 2 and q of x equal to e power 4x. So we can apply the general method. So alpha 1 equal to 3 e power alpha 1x e power 3x. So integral over q equal to x into e power 4x into e power minus alpha 1x. So e power alpha 1 equal to 3 minus 3x into dx. This is first part minus e power alpha 2. Here d minus alpha 2 equal to 2 e power 2x integral over q of x. Q equal to x into e power 4x into e power minus alpha dx minus 2x into dx. So e power 3x. Here e power 4x and e power minus 3x. So bases are equal. Adding powers 4x minus 3x x into e power x dx minus e power 2x x into here also base is equal. So we are adding powers e power 2x into dx. So applying integration of uv dx are by parts. So by parts means u into v1 minus u dash into v2 plus u double dash into v3. So u dash means derivation of u. V1 means integration of V. So U into X into integration of e power x minus U dash. So U dash equal to U equal to X. U dash means derivation of X. 1 V into V2. V2 means integration of V1. Here V1 equal to e power x, integration of e power x plus U double dash. U double dash means derivation of u dash. U dash equal to 1. U double dash equal to 0. So integration of x e power x equal to x e power x minus e power x minus e power 2x. E power 2x into uv. U into u means x e power 2x integration of e power 2x by 2 minus u dash. U dash equal to derivation of x 1 v2. So integration of v1 e power 2x by 4 plus u double dash. U dash means 1, u double dash equal to 0. So on simplification e power 4x into 2x minus 3 by 4. The general solution of equation 1 is so y equal to complementary function plus particular integral, that is yc plus yp. So here yc equal to c1 e power 2x plus c2 e power dx and yp equal to e power 4x into 2x minus 3 by 4. Adding these two solutions, that is solution of given differential equation. So y equal to yc equal to c1 e power 2x plus c2 e power 3x plus yp equal to 1 by 4 into e power 4x into 2x minus 3. And after that, see one more problem. Solve b square plus 4 into y equal to tan 2x. This is also higher order differential equation, means second order. Higher order means second, third, fourth and so on and third. This is second order. So given differential equation is b square plus 4 into y equal to tan 2x. So this is equation 1. So this is the form of f of d into y equal to q of x. Here auxiliary equation f of m equal to 0. In place of d, substitute m. So m square plus 4 equal to 0. So m equal to plus or minus 2i. It can be written as 0 plus or minus I into 2. So which is of the form? These are complex roots, alpha plus or minus I beta. The roots of auxiliary equation are complex, say alpha plus or minus I beta. Then complementary solution is e power alpha x into c1 cos beta x plus c2 sin beta x. So here alpha equal to 0 and beta equal to 2. So substitute these, e power 0x c1 cos 2x plus c2 sin 2x. So yc equal to c1 cos 2x plus c2 sin 2x. Now particular integral. So f of d into y equal to total equation. F of d into y equal to q of x. So sending f of d on right side. So 1 by d square plus y equal to 1 by d square plus 4 into tan 2x. So d square plus 4, it can be written as d minus 2i into d plus 2i. So on simplification, we get the d square plus 4. So this is our partial fractions. So it can be resolving. So 1 by 4i by into 1 by d minus 2i minus 1 by d plus 2i into tan 2x. Resolving into partial fractions. 1 by d minus 2i into d plus 2i. It can be written as a by d minus 2i plus b by d plus 2i. So solving that, we get ab values. So a equal to 1 by 4i, b equal to minus 1 by 4i into tan 2x. Now, so here two fractions are there. Now we solve 1 by first fraction 1 by d minus 2i into tan 2x, that equal to, which is of the form, so direct method of particular integral 1 by or a1 by d minus alpha 1 into q of x. So here 1 by d minus alpha into q of x. Here this formula e power alpha x integral over q into e power minus alpha x dx. So alpha equal to 2i, q equal to tan 2x. So e power I2x integral over e power minus I2x into q equal to tan 2x dx. Then, so e power I2x integral over e power minus I theta. E power I theta equal to cos theta plus I sin theta. E power minus I theta equal to cos theta plus minus I sin theta. So here e power minus I2x means cos 2x minus I sin 2x. So tan 2x means sin 2x by cos 2x into dx. So e power I2x. So on simplification, cos 2x minus I sin 2x into sin 2x by cos 2x dx. So here cos 2x by sin 2x into cos 2x into sin 2x by cos 2x. So cos 2x cancel, we get sin 2x minus I into sin 2x into sin 2x, sin square 2x by cos 2x into dx. So e power I2x. So separating the functions, integral over sin 2x into dx minus I into, so sin square theta equal to 1 minus cos square theta, 1 minus cos square 2x by cos 2x into dx. So e power I2x, integration of sin theta minus cos theta. Here sin 2x minus cos 2x by 2 minus I into, separating these fraction, 1 by cos 2x. 1 by cos means secant. Secant 2x. So cos square 2x by cos 2x. Cos square 1 cos cancel. We get I into cos 2x into dx. E power I to x minus cos 2x by 2 minus integration of secant 2x dx equal to log tan pi by 4 plus x. So log tan pi by 4 plus x, again derivation of sin 2x by 2. So I by 2. Integration of secant 2x dx means 1 by 2 into log of tan pi by 4 plus x plus I into integration of cos 2x sin 2x by 2. I by 2 into sin 2x. So e power minus, taking minus common, and 1 by 2 also, e power I to x minus by 2 into cos 2x minus I sin 2x plus I log tan pi by 4 plus x. So cos theta minus I sin theta, e power minus I theta. In place of theta, 2x. So e power minus I 2x plus I log tan pi by 4 plus x. So this means therefore 1 by d minus 2i tan 2x equal to, so adding these bases equal, so adding powers, e power I to x minus e power minus I to x, e power 0. So e power 0 means 1. 1 into minus 1 by 2 minus 1 by 2 minus I by 2 into e power I to x log tan pi by 4 plus x. This is equation 3. Then replacing minus I, we get second fraction answer 1 by d plus 2i into tan 2x. Here minus of minus 2i. In place of I, replace minus I, minus 1 by 2 plus I by 2 e power I to x log tan pi by 4 plus x. So substitute 3 and 4 in equation 2. This is equation 2. This is equation 2. Here it can be not written. This is equation 2. So adding these two solutions, so we get minus 1 by e power I to x plus e power minus I to x by 2 log tan. So e power x plus e power minus ax by 2 equal to cos ax. So which is of the form cos ax. A in place of a, 2 is there, cos 2x. Log tan pi by 4 plus x. This is particular integral, and the general solution of given differential equation is higher order differential equation or second order differential equation y equal to yc plus yp. That equal to c1 cos 2x plus c2 sin 2x minus 1 by 4 cos 2x log tan pi by 4 plus x. So this is general method of particular integral. Some special cases are there. Rules for finding particular integral in some special cases. So case 1 is, so particular integral of f of d into y equal to q of x, where q of x equal to e power ax. Here a is a constant. So working rule for, in place of q of x, e power ax is there. Then particular integral, put d equal to small a. D equal to small a provided f of a not equal to 0. The place of q of x or pi of x. E power ax is there. Then particular integral, put d equal to small a and will be calculated 1 by f of d e power ax equal to 1 by f of a e power ax provided f of a not equal to 0. If f of a equal to 0. If f of a equal to 0, then this method is failed. Now proceed. So f of d expressed as fraction, not fractions. F of d expressed as factors, d minus a whole power m into pi of d. Here f of a equal to 0. that case only we are using this formula. So then particular integral e power x by pi of a into x power m by m factorial, provided this is pi of a not equal to 0 or f of a equal to 0. Here e power x by pi of a means, so whenever we are substitute to d equal to a, the factor is not equal to 0. The term is pi of a, and whenever we are substituting to d equal to a, the factor is how many? 0. How many times that factor repeated, that is m. So x power m by m factorial. Or we are using in place of this L'Hospital rule also. L'Hospital rule means, so at a time differentiate numerator and denominator. So note point, in order to find particular integral of sine HAX or cos HAX, express the sum, express them as 1 by 2 into e power x minus e, means sine HAX equal to e power x minus e power minus ax by 2, and cos HAX equal to e power x plus e power minus ax by 2. So we are calculating particular integral only exponential function e power ax. Then see one problem. Solve d square y by dx square plus 4 into dy by dx plus 3y equal to e power 2x. This is not operator form. Operator form means in terms of capital D, that is operator form. So given equation can be written in operator form as d square plus 4d plus 3 into y, taking y common. So d square by dx square means capital D square. D by dx means capital D 3 into taking common y equal to e power 2x. This is equation 1. So equation 1 is of the form y f of d into y equal to q of x. So f of d equal to here d square plus 4d plus 3. Auxiliary equation f of m equal to 0. In place of d, substitute small m. M square minus 4m plus 3 equal to 0. So it can be written as, so factors of m plus 3 into m plus 1 equal to 0. So m equal to minus 1, m equal to minus 3. These roots are real and different. Then complementary solution, c1 e power first root into x plus c2 e power second root into x. c1 e power minus x plus c2 e power minus 3x. Then now calculate the particular integral yp or y equal to 1 by f of d into pi of x or q of x. So yp equal to 1 by f of d equal to d square plus 4d plus 3. So pi of x equal to e power 2x. So which is of the form 1 by f of d into e power x. So d square plus 4d plus 3, it can be written as factors of d plus 3 into d plus 1 into e power x, e power 2x. So which is of the form 1 by f of d into e power x. So now calculate the particular integral. Put d equal to a. A means small a, that equal to 2. So substitute 2, f of d is not equal to 0. Then we calculate the direct particular integral e power 2x. In place of d, substitute d equal to 2. 2 plus 3, 2 plus 1. So 5 into 3. E power 2x by 15 is the particular solution of the given differential equation. The general solution of the given differential equation is y equal to yc plus yp. Here y equal to yc equal to c1 e power minus x plus c2 e power minus 3x plus c power, then particular integral plus e power 2x by 15. Next. So solve 4d square minus 4d plus 1 into y equal to 100. Here given right hand side constant term only. So it can be given in operator form only. So auxiliary equation f of m equal to 0. 4m square minus 4m plus 1. So here factors came 2m minus 1, 2m minus 1, m equal to 1 by 2, 1 by 2. So which are real and equal roots. So real and equal, then complementary solution c1 plus, here 2 roots are there, 2 constant, adding c1 plus c2x into e power 1 by 2 into x. Then calculate the particular integral 1 by f of d equal to 4d square minus 2d plus 1 into 100. We have only exponential function of particular integral. So 100 is constant. So constant into e power 0x. It can be written as constant into here x is miss 100 into e power 0x. Put d equal to a. In place of a equal to 0. Substitute d equal to 0. F of d not equal to f of a not equal to 0. 100 by in place of d substitute 100 by 1 that equal to 100. This is particular integral. Then general solution of given differential equation is c1 plus c2x e power x by 2 complementary plus particular. Another different problem. So solve d plus 2 into d minus 1 whole square into y equal to e power minus 2x plus 2 sine hx. So already factors given. E power minus 2x, this is exponential, this is trigonometric. Trigonometric converted into exponential. So f of d into y equal to e power minus 2x plus 2 sine hx. Auxiliary equation f of m equal to 0. So m plus 2 into m minus 1 whole square. Here m plus 2 equal to 0 minus 2, m minus 1 whole square means 1 comma 1. So 3 roots came. The roots are real. These 3 roots are real and 2 roots equal. Repeated twice. Roots are real and 1 root is repeated twice. Then complementary solution y is equal to c1 e power first root into x minus 2x plus these 2 roots are equal c2 plus c3x into e power 1x. Then particular integral 1 by d plus 2 into d minus 1 whole square e power minus 2x plus 2 sine hx. So y equal to taking f of the right hand side. 1 by f of d. So trigonometric function converted into exponential. E power x sine hx equal to e power x minus e power minus x by 2. It can be written as. Okay. E power minus 2x. So then 2 cancel. So left out term e power x minus e power minus x. Okay. So separating the fractions e power minus 2x plus e power x by f of d minus e power minus x by f of d. It can be written as yp1 equal to first fraction, yp2 equal to second fraction, yp3 equal to third fraction. So now calculate the first fraction particular integral yp1. So first fraction e power minus 2x by d plus 2 d minus 1 whole square. So into e power minus 2x. Here which is of the form 1 by f of d into e power ax. Now we have to substitute. We have to substitute put d equal to a equal to minus 2. Then f of d is become 0. So particular integral case or failure. Then proceeding failure case. So it will already converted into factors. So pi of a means whenever we are substituting d equal to a, the factor must be not equal to 0, that is pi of a. So the factor is must be 0. That factor how many times repeated, that is m. So here would d equal to minus 2. Then this factor is 0. This is not pi of a. Would d equal to minus a minus 2. This factor is not equal to 0. This is pi of a means pi of minus 2. That equal to in place of the substitute minus 2. Minus 2 minus 1 whole square 9. And put d equal to minus 2. This factor is 0. Becomes 0. This factor is one time repeated. That how many times that factor is repeated, that is m. So m equal to one time repeated factor is. So m equal to 1. So e power ax means e power minus 2x. Pi of a equal to 9 and x power m means 1. The factor is one time repeated by 1 factor. This is yp1 particular solution. Then yp2 e power x by d plus 2 into d minus 1 whole square. Here, which is of the form 1 by f of d into e power ax. Put d equal to a equal to 1. A equal to 1, then this factor of denominator is 0. F of d is 0. The particular integral case is failure. The failure case of e power ax. So f of a equal to, whenever we are substitute, put d equal to a. So denominator, in the denominator, the factor must be not equal to 0. That is pi of a. So pi of a equal to, put d equal to a, that equal to 1. So d plus 2 is pi of d. So pi of a equal to 1 plus 2, that equal to 3. So put d equal to 1. This factor is 0. This factor is how many times repeated? 2 times. That is m. Means e power x. E power x means e power x by pi of a means pi of 1. That equal to 3. And x power m. M equal to 2x square by 2 factorial. This is yp2. Next, yp3 e power minus x by d plus 2 into d minus 1 whole square. Here put d equal to minus 1, 2 factors are not equal to 0. Directly we solve this. So particular integral is e power minus x by 4. The general solution of particular integral, this one, yp1 plus yp2 plus y3. Adding these three solutions, we get yp. This is yp, total complete yp. The general solution of y equal to yc plus yp1 plus yp2 plus yp3.